All right, our next step in the journey of rational expressions, believe it or not, is adding and subtracting. And it seems strange that we would do adding and subtracting after multiplication and division, because that's not how you learn fractions. That's not how you learn just simple number sense anyway. It's just adding and subtracting before you multiply and divide it. However, with rational expressions, it's actually easier to multiply and divide than it is to add and subtract. So there is a connection here to what we used to do in chapter one, I suppose, when we added fractions. So for instance, let me give you an example. If we had like 2/3 plus 5/3. So I can easily put those together because they have the same denominator, 3. So because they have the same denominator, I can just add the numerators together to give me 7/3. But if I tried an example like 3/4 plus 5/6, it's not quite so easy. I don't make it 8/10. That would be great if it worked that way, but it doesn't. What I need to do is find a common denominator. So I'm looking at the 4 and the 6 and trying to figure out what number can I turn both of those into, but still keep it relatively small. And so the answer there would be 12. So I can turn this into something over 12. So when I do that, I'm going to take this 4 and multiply it by 3. But if I do that to the denominator, I've got to do that to the numerator. And again, I'm turning that denominator into a 12 over here. So 6, I'm going to turn that into 12 by multiplying by 2. Do the same thing in the top. So that's going to give me 9/12 plus 10/12 is 19/12. So nowhere near the 8/10 that we would like it to be. So when we're dealing with rational expressions, our process is the same as adding fractions, but again, more complicated. The first thing we're looking for is, do they have a common denominator? So I'm going to take 3x minus 4 over 2x plus 1, and I'm going to subtract the quantity x minus 6 over 2x plus 1. So my first step is to look at the denominators. And if they're both exactly the same, then that's good news for me. If they're not, then I'm going to have to find out what it is. Now, no matter what I do, if they're already the same, I'm still going to write this out. The least common denominator is 2x plus 1. So what that means is I don't need to change either of my fractions because they already have that. So now I can just combine my numerators. So in the end, I know I'm going to have an expression that is a 2x plus 1 in the denominator. In the numerator, this is where I have to be really careful because we're subtracting this entire expression. And I'm looking for like terms. So I've got a 3x minus x would give me 2x. And I have -4 minus -6. So that means -4 plus 6. So that would give me 2. And so I've put my numerators together. The only other thing I need to look for is potentially if I can factor anything that's left over. And in the numerator, it looks like I can take a 2 out of everything, making it 2 times x plus 1 over 2x plus 1. And nothing here will cancel, and so that's as far as I can go with the problem. It seems so complicated so far. But of course, we're always going to add a little bit of complexity to it. So we're going to take an expression, 3x over x plus 1. And to that rational expression, we're going to add 5 over x minus 2. Now we get into a problem because our denominators are not the same. Calculating the least common denominator is kind of weird. It's kind of unusual, but especially what we want to have happen is we want to look, are there any numbers in the denominator that are outside already? And if they are, that's going to have to be part of our LCD. Then we're looking for factors. X plus 1 and x minus 2 are factors. What we want is all of our factors represented. So when I'm finding the LCD, my LCD is actually x plus 1 times x minus 2. It's both of the factors represented. Now, for instance, if I had something like this x minus 2 quantity squared, I actually have to count that one twice because it does show up in that denominator twice. So that's my least common denominator. But that's not what we had, so I'm going to erase this so we don't get confused and I lose my place and all that other good stuff. So looking back to what we did at the top here, when we changed that denominator, we were trying to turn a 4 into a 12, and we multiplied by 3. we're going to do the same thing here, but instead of an actual number for our denominator, we have variable expressions. So this denominator right here and this one right here, we want to turn it into x plus 1 times x minus 2. So like we did in the top, if I had a 4 and I wanted to turn it into a 12, it was missing a factor of 3. So I multiplied the top and the bottom by 3. I'm going to do the same thing here. When I have x plus 1, my missing factor is x minus 2. So I'm going to multiply the numerator and denominator by x minus 2. In my second fraction, I'm missing the factor of x plus 1. So I'm going to multiply the numerator and denominator by x plus 1. Now I will have a common denominator, which is good news. That's what I'm looking for. X plus 1, x minus 2. Figuring this part out, I'm going to take 3x times x minus 2. That's going to give me 3x squared minus 6x. To that, I'm going to add what I have here. When I take 5 times x plus 1, that's 5x plus 5. And at that point, I can keep going a little bit further. Now I can start putting some like terms together. So I'm going to have 3x squared minus x plus 5 over x plus 1 and x minus 2. One thing I want to make sure of is that numerator doesn't factor, and I'm really not seeing it factor. If I do factors of 3, it'd be 3 and 1. Factors of 5 would be 5 and 1. I don't think there's a way to get us to a negative x in the middle. So I'm going to say that's not factorable, and that's as far as we can go. All right, number 3. Take it up another level here. We have the problem 3x minus 2 over 2x squared plus 4x minus 48. Oh boy, that's going to be a fun one. Plus x minus 3 over x squared minus 16. So again, I'm looking to factor. In the denominator, I can take a 2 out of all those. And I actually can go further with that factoring. X squared plus 2x minus 24 would factor to x plus 6 and x minus 4. Over here with x squared minus 16, I have an x plus 4 and x minus 4. So I am looking to find my least common denominator. And I do have a number in front. I've got a 1 in front of here and a 2 in front of here. So together, the smallest I can make those is a 2. I've got an x plus 6 that only shows up once in any of the factors. I've got an x minus 4 that shows up in both the factors, but it only shows up once in each. So I'm not going to consider it squared. I'm just going to write it out as x minus 4. And then my other factor is x plus 4. That's a big, huge LCD. And that's what we're trying to turn everything into. And so that's my next step. So I know I'm going to get the LCD of x plus 6, x minus 4, and x plus 4. I'm looking to multiply the top of each fraction, the bottom of each fraction by what's missing to get that LCD. So looking at my first fraction, this is what it is fully reduced down. It looks like I'm missing the factor of x plus 4. So I'm going to multiply the top and the bottom by x plus 4. And let's see, that second fraction, I'm missing the 2 and the x plus 6. So I'm going to multiply by 2 times x plus 6. I'm really going to think of that as 2x plus 12, and you'll see why in a minute. All right, now I'm going to do some multiplication in the numerator. I'm going to take x plus 4 times 3x minus 2. And so if I do x times 3x, that's 3x squared. X times negative 2 is negative 2x. These are 12, so that's going to give me a plus 10x. And minus 8. And I'm going to add to that the second fraction doing the same thing. And again, I'm going to use 2x plus 12 because it's going to be easier for me in the end. So 2x times x is x squared, or 2x squared, sorry. Almost messed that one up. 2x times negative 3 is negative 6x. And 12 times x is 12x. So that's going to give me a plus 6x together. and then minus 36. And so I'm looking to put them together. 3x squared and 2x squared is 5x squared. 10x and 6x is 16x. And then I'll have minus 44. All of that divided by 2 times x plus 6 times x minus 4 times x plus 4. And I'm going to do a quick check here of the factoring, and I'm not seeing anything that's going to work. The only factors I can think of 44 are 4 and 11, other than 1 and 44. If I did 4 times 5, that'd be 20, and then I have to do 11. I'm not going to get to 16 in the middle, so there's not much else I can do. It won't happen often where the numerator, once you've got those combined, will factor and cancel, but it will happen sometimes. So you definitely want to be on the lookout for that. So again, adding and subtracting fractions, rational expressions is just like fractions in that you want a common denominator first, and you may need to adjust your fractions to get that. Once you're there, add your numerator